Okay, so we're going to say goodbye to shape, we're going to say goodbye to algebra. It's time to do some good old-fashioned numbers. How bad could they be? And we're actually going to start by reminding you of some stuff that came up in chapter 5. So this chapter is all about proportion, and proportion is a lot of different things in maths, but it's basically to do with the relationship between two numbers. We do this with fractions, we do this with decimals, we do this with percentages. We also do this with ratios, and we're going to look at a few other edge cases as well. So first thing we need to know is how to convert freely between these. We did this in chapter 5, but just as a very quick recap. If we want to go for a percentage to a decimal, all you do is divide by 100. That means you move the decimal point 2 spaces to the left. So 12%, if we divide by 100, gives us 0.12 as a decimal. 3.85% if we divide it by 100, we'll go to 0.0385. Common mistake is just to say 0.385, just to say, well, it has to be that, but no. If we want to go back from a decimal to a percentage, then obviously we do the opposite. We multiply by 100. So if we had 0.46, that would give us as a percentage 46%. 0.028 times by 100, 2.8%. 1.63, 163%. The question you generally get at this point is, well, isn't more than 100% impossible? And the answer is very much no. If you look at anything financial, they are very keen on taking more than 100%. Percentages to fractions, so that's slightly trickier I suppose, but no, you just write it as a denominator of 100 and simplify it if you can. So 39% you would write as 39 out of 100 because percent means out of every 100. And you'd think, can you simplify that? No, you can't. That's as far as it goes. 45%, 45 over 100. Can you simplify it? Yep. We can divide top and bottom by 5. 9 over 20. Can you simplify it? Nope. That's as far as it goes. Fractions to percentages, a little bit more complicated. You kind of want the bottom of your fraction to be a 10 or a 100, ideally, and then you can just read the percentage from the top. You can also multiply by 100, although that might be, if I've got a calculator on me, how would I do it? So let's do it with the first method. So for 7 over 5, I would times by 2 to make it 14 over 10. I would times it by 10 to make it 140 over 100, and then I've got my denominator is 100, and so that is 140%. 3 over 20, I would times by 5, and that would give me 15 over 100, and that would tell me that's 15%. Now these should be things that we're familiar with, but if there's any of this stuff you've forgotten, it's well worth reminding you before we press on with proportion. So the things we haven't looked at so far, we haven't looked at fractions and decimals, and I consider these to be the ones that people struggle with the most. Fraction to a decimal is actually dead straightforward. One option is you can change it to a percentage and change it to a decimal that way. But you can always just divide the top by the bottom, the numerator by the denominator. So if I had 13 over 9 and I said make this a fraction, then all I need to do is how many times does 9 go into 13? Well, it goes in once, and there's a remainder here of 4, so we add on a 0. And does it go into 40? It goes in 5 times. No, 4 times. 4 9s are 36, remainder 4. We stick a decimal place where the decimal place is, and that's going to be 4 again, and that pattern will repeat. We can see that's just going to give us 4 remainder 4 every time. So this as a decimal would be 1.4 recurring. So we use a little dot over it to say recurring. 3 over 8, what about that? Well, we want to put 8 into 3. Make sure you have these the right way round. We want our denominator outside of our bus stop. We probably know that we're going to need to use some decimal places, so let's stick them in. 8 doesn't go into 3, remainder 3. 8 goes into 30, 3 times remainder 6. 8 goes into 60, 7 times remainder 4, because that's 56. 8 goes into 45 times exactly, so this would just be 0.375. If the pattern isn't repeating, you kind of need to go until it does repeat. And then lastly, 3 into 40, or 3 over 40. So we want to do 3 divided by 40. Now remember, with decimals we can make this easier by dividing both sides by 10, and we can say we want to do 0.3 divided by 4, and that'll be exactly the same answer. So here's our bus stop. 4 obviously doesn't go into 0, and it doesn't go into 3 either. Goes into 37 times, remainder 2, goes into 25 times, so this will be 0.075. And lastly, decimals to fractions are actually reasonably straightforward. Whatever your lowest place value is, that's the denominator of your fraction, and then simplify it. So we've got here 0.0142. So if we think about place value, that's tenths, that's hundredths, that's thousandths, and that's 10,000ths. So if we write this as a fraction, it should be over 10,000, because that's the lowest place value that it's actually got. Can we simplify that? Yep, we could divide everything by 2. And I think that's probably as simple as we can make it. 71 doesn't really divide by anything. Yeah, it's prime, isn't it? So yeah, that's as far as we could go. 0.17, that's got a hundredths as its biggest, as its smallest place value. So 100 goes on the base and 17 on the top. And 0.038, we've got tenths, we've got hundredths, we've got thousandths. So 1,000 goes on the base, 38 on the top, and then simplify, we can divide both of those by 2 and make it 19 over 500. And then there's one more, because this is decimals to fractions if they are not recurring decimals. But if they're recurring decimals, we've got a little bit more of a complicated setup. So I've written down here we need to set x equal to our decimal, multiply it so the decimal parts line up, subtract, divide, simplify. This is a grade 7 technique, and it's one that I want to make sure that we're still familiar with as we go back into proportions. So let's say how we do this. Set x equal to the decimal. So we're going to say x is equal to this 0.7 recurring that we're trying to get. Multiply it by 10 or 100 or 1,000 so that the decimal parts line up. So what do I mean by that? What I mean is we're going to need to write out this decimal. So it's 0.7777 ... That's what 0.7 recurring means. And we want to times it, I think, by 10. If we multiply it by 10, then everything will, well, the decimal place will move 1 to the right, we could say, or we could say all the numbers will move 1 to the left. And so we'll end up with 10x is 7.7777 ... with no end to those 7s, because that's what recurring means. And we can see there that we've lined up everything cancelling out. We'll be doing, if we do a subtraction here, then we'll be doing 7 take away 7 is nothing, and 7 take away 7 is nothing, and 7 take away 7 is nothing, and so on. And we'll just end up with 7.000. Now what will we end up on the left-hand side? 10x take away x is 9x. So we'd be able to say 9x equals 7. And then, so that was our multiply it, and then subtract. And then we're going to divide across by the 9 that we've got there, and just say that x is 7 over 9. Simplify if required. There is no simplifying that can be done there. So we set x equal to the decimal, multiply it up, subtract, divide, and simplify. It's quite a nice method, all told. Okay, here's another one. Maybe have a go at this one yourself. Okay, so if I was going to do this, I would start by writing out the decimal. So we've got here that x is equal to 2. Now if we've got 2 dots, that means that the 4 and the 1 repeat as a pattern. So it's 2.414141 ... What would I multiply this by? So if I multiply it by 10, what's the problem here? Well, I end up with 24.141414, and that isn't good because nothing cancels out. I can't do 4 minus 1, I can't do 1 minus 4, I have to write down another infinite decimal. So what we're going to do instead is we're going to multiply this up by 100, and your general safe bet is to multiply it by however many recurring places there are. So here we've got 2 recurring places, we're going to need to times it by 2 zeros. If there were 3 recurring places, we'd times it by 3 zeros. So again, we want these to line up, so we should really put the decimal points in the same spot, and this will go to 241.414141 ... Then we can go ahead and do our subtraction. That will give us 99x this time. And what will it give us on the other side? It will give us 241 take away 2. That's 239 and then everything else would go to 0, wouldn't it? Yeah. So we'll end up with 99x is equal to 239. X is 239 over 99. And we'd have to think, well, can we simplify this? 99 doesn't divide by a lot of things. It divides by 3, and 239 doesn't, because those numbers don't add up to a multiple of 3. Divides by 11, but again, we can't divide that. So yeah, that's as simple as we can make it. Last one, and quite a common one for like how the exam likes to set these out. So again, we're going to say that x equals this. We're going to say that x is equal to 1.3, and then there's not a dot above the 3, so that doesn't repeat, but the other bits do. The 8 and the 5 repeat over and over. What are we going to multiply this by? Well, there are 2 recurring decimals, so we need to times this by 2 zeros. So we're going to use 100 as our multiplier. What will that actually give us? That will give us 138 point, and then everything moves 2 spaces, doesn't it? So it'll be 5, 8, 5, 8, 5, 8, 5, dot, dot, dot. Cool. Does everything line up? Yeah, we've got 5s with 5s, 8s with 8s, 5 with 5s. So, make sure your 8s don't look like 5s. We will do a subtraction. We'll end up with 99x on the left-hand side, and on the right-hand side, just be careful. You know, we know all these are going to be zeros, but this is the thing that catches people out. That's a 5 take away 3. That's a 2. So you'll end up with 137.2, not just 137, which is an answer I have seen many, many times. So let's write that down. We've got 99x equals 137.2. And so in theory, we could divide this across now and say that x is 137.2 over 99. But that isn't simplified. We need to simplify if we can. What's the easiest way of simplifying this? It is to times by 10, make this 1372 over 990. But those are both even numbers, so this can be simplified. We can go to 495 on the bottom if we divide by 2. And then on the top, let's assume we did a little bit of a bus stop here. We want to do 2 into 1372. That goes 6, remainder 1, 8, remainder 1, 6. So 686 over 495. And then we hope that doesn't simplify much further. It doesn't divide by 3 on the top. It doesn't divide by 5 on the top either. I think that's probably as good as we can do. So yeah, let's just double check that though. If we go on the calculator, 686 over 495, yeah, nothing more simplifying. Cool. So there you go. A little bit of a reminder on the bits of proportion that you may have missed out first time round, and it's a nice little guide into our percentages and ratios that we're going to look at next. Cheers.